Hello all. So in today's class we will look at what are called critical points. So in last class we have seen what is the definition of a relative extremum. So you can have a relative maximum or relative minimum for the function, and now we are going to figure out how to find the relative maximum or relative minimum of a function. So for that, first we look at what are called critical points. ഇനി നമ്മൾ കഴിഞ്ഞ ക്ലാസ്സിൽ കുറേ ഗ്രാഫ്സ് കണ്ടു where you have a local maximum and local minimum. So you can see from the graph that at a point where you have a maximum or minimum value, there will be a horizontal tangent line. So the tangent at a maximum or minimum point will be always parallel to the x-axis. So a relative extrema always occur at points where the graph of the function has horizontal tangent lines. So relative extrema, so they will occur at points where the graph of the function have horizontal tangent lines, or the tangent lines will be parallel to the x-axis. So let us look an example of a curve. So consider a curve like this. So at this point you will have a maximum. So here it's a smooth curve, okay. So here you will have a minimum, here maximum. ഞാൻ ഈ എടുത്തിരിക്കുന്ന പോയിന്റിൽ ഇത് പോയിന്റഡ് ആണ്, ഷാർപ്പ് പോയിന്റ് ആണ്, and this is also a sharp point and this is also a sharp point. Now you know that at sharp points the function is not differentiable. So this will be a point of non-differentiability, and these 2 points, they are also points of non-differentiability, and at these points, at these 3 points, the function will be differentiable. Here if you look at the tangent at this point, so tangent will be parallel to the x-axis. Ivide tangent will be parallel to the x-axis, so here also tangent will be parallel to the x-axis. Don't go with the figure, so this is just the idea. From figure it doesn't look like parallel, okay. So the tangent at a point of maxima or minima, so the tangent will be always parallel to the x-axis. So you will be having horizontal tangent lines at a point of extrema. Now you can see that at the extrema can occur at points of non-differentiability also. അപ്പം ഈ ഗ്രാഫ് നോക്കുമ്പോൾ ഈ പോയിന്റ് ഒരു ലോക്കൽ മാക്സിമം പോയിന്റ് ആണ്, അതുപോലെ ഈ 2 പോയിന്റ്സും ലോക്കൽ മിനിമം പോയിന്റ്സ് ആണ്. ബട്ട് യുവർ ഫങ്ഷൻ നീഡ് നോട്ട് ബി ഡിഫറൻഷ്യബിൾ അറ്റ് ദീസ് പോയിന്റ്സ്. സോ ഇൻ ജനറൽ the points where you can have a relative extrema are called generally the critical points. So in general we define a critical point for a function f to be a point in the domain of the f at which either the graph has a horizontal tangent line allengi the function is not differentiable. So these are the 2 things we have obtained from this figure. So from this figure it gives us an idea that a relative extrema can occur at a point where the function is not differentiable. So a relative extrema can occur at a point where function is not differentiable, and by critical points we mean, so a critical point is a point for which, so that's a point in the domain of f at which either graph of f has a horizontal tangent line or f is not differentiable. So this is the definition of a critical point. So they are the points in the domain of a function where it has a horizontal tangent line or it is not differentiable. So critical points കണ്ടുപിടിക്കുമ്പോൾ നമുക്ക് രണ്ട് set of points നോക്കണം. The first set of points is where f has a horizontal tangent line, and the second set of points is where your function is not differentiable. Now the first set of points are called as the stationary points. So stationary points are points where the function has a horizontal tangent line. So basically your critical points are of two types, and the points where the function has a horizontal tangent line is called a stationary point. So that is called a stationary point. So that is how we define a stationary point. So at stationary point you will have f dash of x equal to 0. So we call x a stationary point of f if f dash of x is equal to 0. So that is the definition of a stationary point. So f dash of x must be equal to 0 at a stationary point. Now let me give the formal definition of a critical point. So the formal definition of critical point is, so suppose that f is a function defined on an open interval containing the point x naught if f has a relative extremum at x equal to x naught, then x equal to x naught is a critical point of f. So that is either f dash of x naught is equal to 0 or f is not differentiable at x naught. So that is the conclusion of our lecture. So if you have a function f defined on an open interval containing the point f naught, and if f has a relative extremum at x equal to x naught, then x equal to x naught is a critical point of f. So that is either f dash of x naught is equal to 0 or f is not differentiable at x naught. So critical points are points where the function has a relative extremum, and at the critical points your function can be having a zero derivative, or the function is not differentiable at all. Now if f dash of x is equal to 0 at a critical point, so such points are called stationary points. So those are the definitions. So now let us see a few examples of how to find the critical points. So the first question is, so find all the critical points of f equal to x cube minus 3x plus 1. So for the critical points, so we will first look at what is f dash of x. So this is a polynomial function. Again the derivative is going to be a polynomial. So the function and its derivative will be differentiable everywhere. So f dash of x will be 3x square minus 3. So it is differentiable everywhere. So f dash of x equal to 0 implies, so 3x square minus 3 equal to 0, that is x square is equal to 1. So that implies x will be equal to plus 1 or minus 1. So therefore the critical points are x equal to 1 comma minus 1. So those are the critical points. So there are no points where the function is not differentiable. So these are the only critical points. Now the second question is f of x equal to 3x raised to 5 by 3 minus 15 x raised to 2 by 3. So if you look at f dash of x is 3 into 5 by 3, x raised to 5 by 3 minus 1 varum, minus 15 into 2 by 3, x raised to 2 by 3 minus 1. So that will be 5 x raised to 2 by 3 varum, minus 10 x raised to minus 1 by 3. So that is 5 x raised to 2 by 3 minus 10 by x raised to 1 by 3 varum. So that will be 5x minus 10 by common denominator x raised to 1 by 3. So therefore f dash of x ennu parayunnathu 5 into x minus 2 by x raised to 1 by 3. So f dash of x equal to 0 implies x is equal to 2, and also at x equal to 0. So you can see that at x equal to 0 function is not differentiable. So that implies, so critical points are x equal to 0 and 2. So those are the example of the critical points. Now we will see one more problem. So the question is to locate all critical points and identify the stationary points. So we have f of x equal to 4x raised to 4 minus 16x square plus 7. So when you take f dash of x, so that is 16x cube minus 32x. So f dash of x equal to 0 will give 16x x square minus 2 equal to 0. So that gives x equal to 0 and plus or minus root 2. So the function is differentiable. So you can see that it's a polynomial. So function is differentiable everywhere. So therefore all the critical points will be stationary points. അപ്പോൾ നമുക്ക് എല്ലാ critical pointsഉം കിട്ടുന്ന f dash of x equal to 0 ആയിരിക്കും. So therefore the stationary points are x equal to 0 and plus or minus root 2. And we will see one more question. So we have f of x equal to x plus 1 by x square plus 3. So f dash of x എടുക്കുമ്പോൾ use quotient rule, we will get x square plus 3 whole square, x square plus 3 into 1 വരും minus x plus 1 into 2x. So that will be 3 minus x square minus 2x by x square plus 3 whole square. So that will be equal to minus of so you have x square plus 2x minus 3 by x square plus 3 whole square. So that will be equal to minus of x plus 2x അല്ലേ വരുന്നപ്പോൾ. ഓക്കെ, അപ്പോൾ x plus 3 x minus 1 by x square plus 3 whole square. So that is f dash of x, and for all the x values your denominator cannot be 0 for any എപ്പോഴും പോസിറ്റീവ് ആയിരിക്കും. x square plus 3 is always positive, so the denominator is never 0 for any real number x. So therefore f dash of x equal to 0 implies x is equal to 1 or minus 3. So therefore the critical points are x equal to 1 and minus 3, and the function is differentiable at these points. So that implies the stationary points will be, so they will be the stationary points also. So stationary points are 1 and minus 3. So that is the required stationary points. With this we will conclude today's class. Thank you.